Okay, this lesson is about air pressure, and basically our goal is to learn the difference between low and high pressure and to see the different movements in pressure, what it does for weather. So let's have a look. High pressure, that's a photo of the sky in the high pressure systems. They're also called anticyclone. It's called an anticyclone because it's a large body of sinking air that produces an area of high pressure on the Earth's surface. High pressure systems are normally found in the upper troposphere where there's little moisture. So when we think of high pressure, we think of clear blue skies. Why is that? Because there's little moisture, and that moisture forms clouds. So that's why it's clear. And the weather normally associated with high pressure is in summer hot, sunny days. In winter, it's sunny days, obviously not, still can be cold. So get out of this idea that high pressure means hot weather. It means clear skies. So basically, it's a high pressure system because there's little wind as well, because wind is the movement of high pressure to low pressure. So when we've got large bodies of high pressure, we don't have that much wind. It's very gentle, so wind velocities are low. That's why when you see a high pressure system on a synoptic chart, the isobars are far away, whereas we see a low pressure system, they're close. The closer they are, the windier the conditions are. Like I said, so weather conditions in a high pressure system are very gentle, clear skies. Low pressure system, they're called cyclones. Now you might be thinking cyclones only happen in the tropics. No, they're not. That's a tropical cyclone, an intense cyclonic period of low pressure. A cyclone is a body of rising air that produces relatively low atmospheric pressure. So high pressure sinks, low pressure rises. The reason why we get those tropical cyclones, that rising of air is very intense and cools the air very quickly. That's why skies become very angry, grey skies and so on. They are formed when there's lots of moisture on the earth. So that's why in the tropics, when we've got that humidity, particularly over oceans, that the ocean temperature is pretty warm. That's where we get the rise of the air and why we get tropical cyclones. As that air does rise, condensation takes place. So that's where liquid becomes, a gas becomes a liquid, and that's where we get the potential for rain. So the weather associated with low pressure is unsettled weather. We get lots of cloud. Clouds can change from colour depending on obviously the rise and the cooling of the air. The angrier the grey looking the cloud, the more likely there's going to be a storm. Also, we get lots of wind. Some of the winds are stronger there. That's all to do with the rising of that air, because it's getting high pressure turning into low pressure. High pressure only goes into low pressure. Low pressure can't go into high pressure. And this diagram really helps to explain the different types of pressure. So on the left hand side you've got the low pressure. We've got air flowing in, then it's forced, because it's warm, to rise, and then obviously it will condense and fall back down as cold air. So if you look at the high pressure system, the cold air will start to sink. That's why low pressure goes into high pressure, not the other way around. Obviously, thinking about atmospheric processes, how does the air become warmer? It's when it comes in contact with the ground. So that's why low pressure, the warm air rises, then cools, and then as in the high pressure system, it sinks. And that's when we're talking about the atmospheric processes happening. Obviously in the atmosphere, we've got that movement of air from hot to cold. Okay, so it all starts linking up, and that's why it's really important to look at air pressure, because it affects the weather. And these are the patterns of movement within the pressure cell. So in the northern hemisphere, a low pressure goes anti-clockwise and the high pressure system goes clockwise. In the southern hemisphere, it's the opposite. So for Australia, low pressure systems go in a clockwise direction, high pressure systems go in a clockwise position. That's why if we get a high pressure system normally in Western Australia, it will eventually travel across the whole of Australia and hit us a few days later. So when we're looking at weather systems, weather patterns, we look at roughly what's going to be happening in Western Australia, and that's what will happen to Eastern Australia eventually, unless there's something coming in from the Pacific Ocean in terms of, like, you know, tropical cyclones, and that's when we get an easterly storm. That's when we get intense low pressure systems. Okay, so that's the difference between low and high pressure. That's the movement of air pressure systems, and you'll see that it does affect weather.